All right, Assalamu alaikum. Let's start the lesson. So my camera will stay off today. So we're going to do trigonometric identities. Uh, you already know from AS that tan theta equals sine theta by cos theta. And also from AS, you know that sine square theta plus tan square theta equals 1. Now in AS, A levels, we have two more identities. First one is 1 plus tan square theta equals secant square theta. And the other one is 1 plus cot square theta is equals to cosecant square theta. And we already know what is secant, what is cosecant, and what is cot. Let's quickly revise. What is secant theta? Secant theta is reciprocal of cos theta. So secant theta is 1 over cos theta. Then we have cosecant theta. So cosecant theta is actually 1 by sine theta, reciprocal of sine. And similarly, cot theta is reciprocal of tan. All right. We've already proved identities in AS. We're going to prove some more in this lesson. And of course, we'll be using the two new identities we've learned, plus the old identities from AS. Okay. So the first question is, prove the following identity. Part A is 1 by secant theta minus tan theta is identical to secant theta plus tan theta. You have to prove that the left-hand side can be written as the right-hand side or vice versa. All right, so let's start. I'm going to start with the left-hand side and show that it's equals to the right-hand side. Okay, so the original identity or the original expression is 1 over secant theta minus tan theta. One way of doing this question is that here we just have a numerator. There's no denominator. And what is the numerator? The numerator is secant theta plus tan theta. And at the left-hand side, the numerator is 1. So what we can do is multiply and divide this at the left-hand side. So we can times it with secant theta plus tan theta, because our objective is to get this in the numerator. So we can multiply it and divide it. Okay, done with that. So we have the required numerator. Numerator is now secant theta plus tan theta. However, we still have a denominator. In the denominator, we can use the identity A minus B times A plus B from O levels. What is the identity? A plus B bracket A minus B, that is A square minus B square. So that means this is equals to secant square theta plus tan square theta. And we already know that this would be equals to 1. Secant square theta plus tan square theta is 1. So this is 1. And we have the required form. This would be secant theta plus tan theta. So we have proved that this is actually identical to this. Any questions here? There's no one fixed way of proving an identity. There are more than one ways of doing it. Let's see if we can figure out some other way of this. Okay. So what do we know about secant theta? Secant theta is 1 upon cos theta. And what do we know about tan theta? Tan theta is sine theta by cos theta. So I'm going to break this down. So we have 1 in the numerator and the denominator is 1 by cos theta minus sine theta by cos theta. I'm going to write this as a single denominator. So we have, excuse me, 1 upon 1 minus sine theta whole divided by cos theta. Now in the next step, this can go in the numerator and this can be cos theta upon 1 minus sine theta. Now what can be done? Achha. Again, what we can do is we can multiply and divide this fraction with this value. Let's see, 1 plus sine theta upon 1 plus sine theta. This is kind of like rationalizing, but you haven't done complex numbers yet, so you wouldn't know. But one way of proving an identity is that you multiply and divide with this same denominator by changing its sign. So we multiplied and divided it with 1 plus sine theta. Now, why did we do that? Because now when we solve the denominator, what do we get? We get 1 square minus sine square theta in the denominator. And in the numerator, we have cos theta times 1 plus sine theta. Now, what is 1 minus sine square theta? You know this identity from AS? मैंने साइन तो यहाँ इतनी बड़ी गलती हुई है और किसी ने नहीं बताया हुआ यहाँ क्या गलती है ये तो नहीं पढ़ी थी हमने AS में the identity was हाँ exactly this is supposed to be cos sine square theta plus cos square theta equals 1. So that means when sine goes to the other side, it becomes 1 minus sine square theta. So 1 minus sine square theta is actually equals to cos square theta. So we get cos square theta in the denominator. So cos theta times 1 plus sine theta upon cos square theta. So this and the square cancels out. So I'm going to split the denominator now. 1 over cos theta plus sine theta by cos theta, which is 1 over cos theta is what? Secant theta. Reciprocal of cos is secant theta. Plus sine theta over cos theta is tan theta. So we got sine secant theta plus tan theta. I think the first method was shorter, but of course, when you start a question in a test and in exam, तो इतना तो click नहीं करता कि कौन सा method smaller है, shorter है, कौन सा is more time consuming. So you may use any method. In the end, it gets you to the correct answer as long as you're using the correct identities. Okay, so this was the very first question. Let's practice another one from the identities. I'm going to clear this. Part B. B is secant theta minus 1 upon tan theta should be identical to tan theta over secant theta plus 1. Now again, it's up to you whether to show that the left side is equal to the right side or vice versa. I'm going to start with left and show that it's equal to the right hand side. So secant theta minus 1 upon tan theta. Achha, now I'm going to use the same approach as earlier. At the right hand side, there's tan theta in the numerator. So I'll need tan theta here as well. So I'm going to multiply and divide by tan theta. Again, this is just one approach. कि न्यूमरेटर में tan theta आना चाहिए. इधर हम इस fraction को tan theta से multiply कर देते हैं and divide. So the denominator becomes tan square theta. And the numerator is secant theta minus 1 times tan theta. Okay. Now we know what is tan square theta equals to. Tan square theta from this identity, tan square theta is equals to secant square theta minus 1. So I'm going to replace tan square theta with secant square theta minus 1. And numerator is secant theta minus 1 times tan theta. Okay. Now in the denominator, I'm using the property a square minus b square, which is a plus b, a minus b, the algebraic identity from O levels. So this would be secant theta minus 1 in one bracket, secant theta plus 1 in the other, and this gets cancelled. And we have tan theta over secant theta plus 1, and that is what we were supposed to show. This is tan theta upon secant theta plus 1. Done? एक और तरह से भी करके देखते हैं. We have secant theta minus 1 upon tan theta. Achha, now we need this in the denominator at the right hand side. So I'll multiply this in the numerator as well as in the denominator. So times secant theta plus 1 divided by secant theta plus 1. Okay. Now the numerator is a plus b and a minus b, which is a square minus b square. So we have secant square theta minus 1, and we have tan theta, and we have secant theta plus 1. Okay. So secant square theta minus 1 can be replaced with tan square theta from this identity. So secant square theta minus 1 is actually tan square theta. Now the tan theta in the numerator and denominator cancel out, and we get the required identity. Similarly, you can also prove this identity. We're not going to do it till the very end. Maybe you can take it as homework. And you can prove that you can also use the reciprocal trigonometric functions to prove that the left hand side is equal to right hand side. Instead of secant theta, you can write 1 by cos theta minus 1. And instead of tan theta, you can write sine theta by cos theta. You can further solve it, take LCM, cross out the sine cos thetas and somehow get the right hand side. Okay, ये homework में कर लेना. We can't be doing one question in 3 different ways. We need to move on. So that was part B. Part C. Cosecant theta plus cot theta is identical to 1 over cosecant theta minus cot theta. Okay. Let's see. In the denominator, we should have this. So I'm going to multiply and divide this at the left hand side. So we have cosecant theta plus cot theta times cosecant theta minus cot theta upon cosecant theta minus cot theta. Now in the denominator, we have the required form cosecant theta minus cot theta, and numerator would be a plus b times a minus b, which is a square minus b square. So it's cosecant square theta minus cot square theta. Okay, and using this identity, the numerator is equals to 1. So this would be 1 upon cosecant theta minus cot. Here. Let's practice one more question and then move on to the next topic. Part D. Secant theta upon secant theta plus tan theta plus tan theta upon secant theta minus tan theta. This should be identical to 1 plus 2 tan square theta. Now we have two fractions at the left hand side, but a single fraction at the right hand side. So what we can do, you have a single fraction there. So what we can do, take LCM at the left hand side, change it into a single fraction. Let's start there. So we have secant theta plus tan theta times secant theta minus tan theta. Again, the property a plus b times a minus b, which is a square minus b square. So secant square theta minus tan square theta, that is the denominator. In numerator, we will be cross multiplying. We have secant theta times secant theta minus tan theta plus tan theta times secant theta plus tan theta. So let's just first simplify the denominator using this identity, this becomes 1. Secant square theta minus tan square theta equals 1. So instead of the denominator, I'm writing 1. And let's expand the numerator. Secant square theta minus secant theta tan theta plus secant theta tan theta plus tan square theta. These two cancel out, and in the numerator we have secant square theta plus tan square theta, and the denominator is 1. Still we don't have this, but I guess we're close. Okay, so the final expression does not have secant in it, instead it has tan in it only. So do we have an identity that changes secant into tan? Yes, we do, this one. So secant square theta can be replaced with 1 plus tan square theta. So this becomes 1 plus tan square theta and another tan square theta. So now we have the required form 1 plus 2 tan square theta. That is the proof of the identity. All right. Let's move on. That's enough practice for the identities. You'll get more questions like this in the worksheet. Now let's discuss the addition and subtraction formulas of identity of trigonometry. Addition and subtraction formulas. Again, just like the identities, you will have these formula given to you in the MS19 document, in the formula sheet. Addition and
compound angles होते हैं, compound angles.
हैदर दोबारा बोलो.
मैम जो compound angles होते हैं इसकी बात कर रहे हो आप?
हाँ जी. कंपाउंड एंगल्स किसकी बात कर रहे हैं? sin 2a cos 2a उसकी?
नहीं मैम, मतलब कि ब्रैकेट्स के अंदर एडिशन जो होती है या सब्ट्रैक्शन.
ठीक है. यस. sin a plus b sin a minus b cos a plus b cos a minus b tan a plus b, where a and b are angles, and tan a minus b. So sin a plus b is sin a cos b. Sin stays the same, plus cos a sin b. Similarly, sin bracket a minus b would be sin a cos b. The sign in the middle stays same, negative, cos a sin b. With cos a plus b, it's cos a and cos b together. Then the sign flips, negative, and then sin a sin b. Similarly, with cos a minus b, it's going to be cos a cos b, sin flips, plus sin a sin b. For tan a plus b, the numerator is tan a plus tan b. The sign is the same. And then divided by 1 minus tan a tan b. So the numerator sign is the same, the denominator sign is flipped. Similarly, here we have tan a minus tan b upon 1 plus tan A tan B. These are the addition and subtraction formulas. Now let's take a look at the kind of questions they get tested in, because the formulas are already given. So फिर questions किस तरह के आते हैं? Here's a question: express tan pi by 3 plus x in terms of tan x. This is the question. Let me get my calculator. So you will find the formula in the formula sheet for tan A plus B, like we just discussed. It's tan A plus tan B upon 1 minus tan A tan B. So let's substitute the values in the formula. We have tan pi by 3 plus tan x upon 1 minus tan pi by 3 times tan x. Now, since it's pi by 3, that is your hint that you have to use radians and not degrees. And mostly in trigonometry, unless specified in the question, you always have to keep the mode, the unit as radians, not as degrees. Okay, always, unless the question says otherwise. Question में अगर degree mentioned है, then only you change it to degrees. Otherwise, you stay in radians throughout. Okay, so what is tan pi by 3? Tan pi by 3 is, I believe, square root of 3. So that would be square root of 3 plus tan x 1 minus and square root of 3 tan x. That's the answer. Another question? Given that sin A equals 3 by 5 and cos B equals 12 by 13, where A is obtuse and B is acute. I just need a minute. I'm going to go sit somewhere else. Okay. Given that sin A is equals to 3 by 5, cos B equals 12 by 13, where A is obtuse and B is acute, find the exact values of part A tan A, second, part, second, this is lacking. Okay, part A is tan A, part B sin B, part C cos A minus B, and part D is tan A plus B. Let's start with looking at sine A equals 3 by 5 and cos B equals 12 by 13. What do we know about A? Says A is obtuse. So I'm going to plot an angle in the second quadrant. Let's say this is A. Now, if this angle is A, I'm going to draw a right angle here. And this is sine alpha, or sorry, sine A is equals to 3 by 5. So if this is theta, then this would be 3, the perpendicular or the opposite, and this would be 5, the hypotenuse. So then what would be this length? How will we find this length?
4.
4. How did you do that? Pythagoras theorem. 5 square minus 3 square, square root gives us 4. So we have length 4. So what do we know about cos of an obtuse angle and tan of an obtuse angle? From AS, we know that in the first quadrant, all three trigonometric ratios are positive. The second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. Add sugar to coffee. So if sine A is 3 by 5, then what will be cos A? Cos is base over hypotenuse or opposite over, adjacent over hypotenuse. So that would be 4 over 5. However, we know that in the second quadrant, cos is negative. So this has to be negative 4 over 5. Similarly, tan A will be base over perpendicular over base or opposite over base. Sorry, through proper brushing. So perpendicular over base or to opposite over adjacent side. So that's going to be 3 over 4. However, we also know that if an angle is obtuse, that is, if it is in the second quadrant, only sine theta is positive. So tan will also be negative. So we know that sine A is this, and then cos A is this, and tan A is minus 3 by 4. Now let's take a look at B, cos B. B is acute, so B is going to be in the first quadrant. B will be somewhere over here. And then base, cos is curly brown here, base over hypotenuse. So 12 is here and 13 is here, or cos is adjacent over hypotenuse. So find the third length using Pythagoras theorem again. So that's going to be square root 13 square minus 12 square, which I believe comes out to be square root of 25. So that would make this 5. So now we know that cos B is 12 over 13, already given in the question. Sine P would be perpendicular over hypotenuse or opposite over hypotenuse, and tan B would be perpendicular over base 5 over 12 or opposite over base 5 over 12. And we know in the first quadrant, all three trigonometric ratios are positive, so I have not placed a negative sign anywhere. Okay, now we're ready to take a look at the actual question. Part A says find the value of tan A. We already have that. Tan A is minus 3 by 4. Sine B is 5 by 30. We know from here, we've already found that out. Okay. Cos A minus B, we're going to use the subtraction formula, which is cos A times cos B minus sine A times sine B. So cos A is minus 4 by 5. Cos B is given in the question 12 by 13. Minus sine A is also given in the question 3 by 5. And sine B is 5 by 13.
मैम ये साइन फ्लिप नहीं हो जाएगा?
किसमें?
प्लस नहीं हो जाएगा?
हाँ, बिल्कुल बिल्कुल, yes, my bad. This would be plus in between. Thank you. Okay, give me the answer for this, please.
minus 33 over 65.
Probably. बाकी देख के बताएंगे. जी. Are we getting the same answer as Heather's? Minus 33 over 65. यही आ रहा है सबका.
यस.
Okay. So that gives minus 33 by 65. All right, let's do part D. Tan A plus tan B. So that's going to be tan A plus tan B upon 1 minus tan A tan B. Tan A is minus 3 by 4 plus tan B is 5 by 12 upon 1 minus tan A is minus 3 by 4, tan B is 5 by 12. Yes, what's the answer?
minus 16 by 63.
Okay. Minus 16 by 63. Okay. Moving on. We're going to talk about double angle formulas now. Sine 2 theta, cos 2 theta, tan 2. Okay. Sine 2 alpha is equals to 2 sine alpha cos alpha. Alpha could be theta or whatever. In fact, let me just change this into theta. Okay. Similarly, cos 2 theta is equals to cos square theta minus sine square theta. Also, by using this identity, cos square theta plus sine square theta equals to 1, you get two more variations of this. So this is also equals to 2 cos square theta minus 1 by using this identity, and also 1 minus 2 sine square theta. So cos 2 theta can be expressed as either one of these three identities or expressions. Okay. And then lastly, tan 2 theta, which is equals to 2 tan theta upon 1 minus tan square theta. Again, all of these formulas would be given to you in the formula sheet. Okay. Let's take a look at the questions from this topic. Question is that sine alpha equals 2/3, where A is obtuse. Find exact value of cos A. Part A is cos A. Part B is sine 2A. And part C is tan 2A. Okay. Again, since A is obtuse, let's plot it in the second quadrant. I'll do it here. So it's here. And in the second quadrant, we know only sine is positive. So sine A is already given to us. Sine A is 2/3. So I'm going to draw a right angle here, right angle triangle. This is theta. So sine is some people have. So that would be 2. That would be 3. Use Pythagoras and find this length, which is going to be square root 3 square minus 2 square, which is what, square root of 5. So this length is going to be square root of 5. Okay. So now cos A is going to be curly brown hair. Base is square root of 5. Hypotenuse is 3. However, this sign is negative because only cos is positive in the second quadrant. Similarly, tan A is through proper brushing 2/3. However, this is also going to have a negative sign with it because tan is negative in the second quadrant. 2 over under root 5 through proper brushing. So minus 2 upon under root 5. Okay. Now we already have the answer for part A, that is 2/3. For part B, it's sine 2A, which from the identity is equals to 2 sine A cos A from this identity. So 2 sine A cos A, which is 2/3, and negative under root 5/3, which is minus 4 square root of 5 upon 9. That is the answer for part B. Part C, tan 2A equals 2 tan A, 2 tan A over 1 minus tan square A. So that is 2 times tan A is minus 2 upon under root 5 upon 1 minus 2 upon square root of 5 whole square, because it's tan square A. So you square the tan A's value. This would give us what? Positive. Enter all of this in your calculator once, numerator, denominator, everything together, and tell me what we get. I'm getting -4 times square root of 5. Did you guys try this? जी आया ये आंसर?
जी मैम सेम आ रहा आंसर है।
ठीक है, all right. I think let's end the lesson here. 2-3 चीजें रह गई हैं, but वो अभी खत्म नहीं होंगी इस लेसन में. So tomorrow we'll just conclude this theory of trigonometry and inshallah start the worksheet as well. Right? So take care and see you tomorrow inshallah. Allah Hafiz.
अल्लाह हाफिज़।